Hi, in this video, I wanted to just talk about analog signals and digital signals and think through what are the differences between this analog and digital signals, right? You would have often heard of digital systems. Now, most electronics or most consumer electronics that we use are digital systems. So, for example, your mobile phone, the computer, an iPad, most televisions that we get today are all digital devices. However, you must also have heard of things like analog, for example, analog audio, and things of that kind, right? So, what is the difference between these two? Okay, so here goes. So if I think about an analog signal, there are two axes on which the analog signal is defined, right? So an analog signal is basically, you can define it like this. On the x-axis, you can plot the time, and on the y-axis, you can talk about the amplitude, whatever the units of that amplitude is, right? An analog signal is a signal that is continuous both in the time domain, in the time axis, and the amplitude axis. What do I mean by that? What I mean by that is that uh, in the time axis, the analog signal is defined for all time instants. Okay, so if I have a point in my signal which is at this point, and let's say this corresponds to time t1, and let's say there's another time here, and this is t2. How many times, how many instants of time between t1 and t2 is this signal defined for? The answer is infinite. So the resolution, the time resolution of your analog signal is infinite. Okay, now similarly, if we talk about the amplitude axis, the amplitude resolution of your analog signal is again infinite, though it may have some limits on the range. Like similarly in time as well, you may say, well, the ECG signal that I started recording only starts at 1 second, time t equal to 1 second. Yes, before that the signal didn't exist. But once it starts existing, in that interval, your time resolution is infinite. And similarly, the amplitude resolution in the range of the signal is infinite, at least theoretically, right? Now, digital signals are very, very different. Now, how would a digital signal look like? So let's plot another time axis and think about this. So let me plot the digital signals here. So again, you have the time, and again, you have the amplitude for a digital signal, right? But in a digital signal, the signal is only defined for certain time instants. So for example, it is defined at time t equal to 0, and then it is defined at this time instant, then this one, 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 and so on and so forth. Okay, it is not defined for any time in between those time instants. So for example, if I say, well, tell me the value of the signal at this point, okay, which is in between two time instants where the signal is defined, you say, well, I don't know, because a digital signal is not defined at that point. Okay, and similarly, the digital signal is also in just a similar way, it's also cannot take all amplitude values, it only can take certain amplitude values. Okay, so it cannot take all the values that exist, but it can only take a few values. Now, the process of getting the time instance on which the digital signal is defined, okay, this is called sampling. So imagine how you would go from the analog signal, which has a continuous time domain, and get an equivalent digital signal. The way you're going to do it is you're going to pick up the values of this analog signal at certain instants of time and not worry about the signal at other instants of time. right? So that process is called sampling. Now, similarly, the process of dividing up the amplitude scale into certain values at which are the only values that the signal can take is called quantization. Okay, and we'll talk about quantization and sampling in the next few videos. But for now, hopefully you can see how what is the difference between analog signals, which are continuous both in time and amplitude, and digital signals, which are discrete. We use the word discrete in both time and amplitude.